Welcome to ERC Tipsnology. In this video, we will be learning superposition theorem using a voltage source, a current source, and 5 resistors in series parallel circuit. So let's start. Here, I'm drawing the voltage source on the left side of the circuit, and I'll be using 3 resistors at the top. I have here one current source on the right side of the circuit, but let's first draw the 3 resistors at the top part of the circuit, and in the middle part I'll draw 2 resistors, and then we have the ground at the bottom. Let's put plus minus on the voltage source 10 volts and the current source of 100 milliamperes, and let's label all of the 5 resistors from R1 to R5. So the R1 will be equal to 300 ohms, R2 is 400, R3 is 500 ohms, R4 is 200, and R5 is 300 ohms. Now let us use superposition theorem in order to calculate for the currents and the voltages of these 5 resistors. So by superposition theorem, let's start by cancelling one of the sources, and let's draw it again with the voltage source but without the current source. So we have R1, R2, R3, R4 connected still in the circuit, but the open circuit IS will make the R5 to be disconnected in the circuit also. When we have a current source, we keep it open, and the resistor in series with it will be gone in the circuit. So we have here the circuit, and let's draw it again, this time without the IS and without the R5. And as you can see here, we have a simple series parallel circuit. We have the R5 current will be equal to 0, so I5 will be equal to 0 milliamperes. And then this is with respect to Vs. Now, with the resulting circuit, we will be calculating the current I1, current I2, I3, and I4 with respect to the Vs. And this is I total, and that would be equal to the I1 also, and going down is I2, and to the right is I3, going down is I4. And let's write the equal sign for the I4. This is equal to I3 because they are in series, or we can say I34. And for I3, that would be equal to I1 minus the I2. For I2, we can use the current divider rule, R over R plus R, multiply with I, and the I will be I1, and the R opposite R2 will be R34, and the sum of R2 plus R34 will be the denominator. In the I1, that would be equal to I total, and by Ohm's law, it's Vs over RT with respect to the voltage source. Now, the next step is we have to get the R total with respect to Vs, and to do that, we have R1 in series plus the R234. But we don't know R234, so let's write R234 equals R2 parallel with R34. And we don't know R34, and so R34 is the series of R3 plus R4. And we will start with R34 with the values of 500 and 200 ohms. So the sum would be 700 ohms. And then we can now calculate for R234, which is the parallel of R2 and R34. So the product over the sum would be 400 multiply with 700 over the sum of 400 plus 700. And the R234 will be calculated now. Let's use the scientific calculator and calculate the answer for R234. we got the answer of 254.545 ohms. Now that we know the R234, we can calculate now the R total, which is equal to R1 of 300 plus the answer of R234, 254.545. Then we will calculate it together. 300 plus 254.545 would give us 554.545 ohms. And because we already know the RT, we can now substitute it over here for the I1 calculations or IT, and we will get 10 volts divided by 554.545 volts. Let's calculate the value. 10 over 554.545 would give us 0.018032 amperes, or let's move the decimal point 3 spaces to the right. That would give us 18.038 milliamperes for I1 with respect to Vs. Now for I2, now that we know the R34, we got 700 multiplied with 18.0328 milliamperes divided by the R2 of 400 plus the 700 of R34, and we will multiply it with the current I1, and we will get the answer for I2 with respect to Vs equals 11.475 milliamperes. And then we can now calculate for I3 with respect to Vs. So getting I1 with our answer from here, 18.0328 milliamperes minus I2, which is 11.475 milliamperes, and we will get the answer for I3 with respect to Vs. And the answer will be 6.5578 milliamperes. Now we can find the value of the next current, which is I4, and that's only equal to I3, and we will also have I34. And let's just copy the answer in I3, which is 6.5578 milliamperes. And there you go. We already have all the 5 currents with respect to Vs. So in superposition, we have to draw another circuit. This time, we will keep the current Is, but we will cancel the Vs by substituting it with a shorted line. So the Vs now is substituted with a shorted wire, and we got the R1 to R5 again, and the Is will produce the I total of 100 milliamperes, and this is going to the left side of R5. And so we don't need to calculate for I total now. Because of that, I5 is in series with the current source. Therefore, I5 will also be equal to I total. Let's draw the I4 and the I3 here, going downward and to the left, and we will be able to calculate for I5 now. Because I5, we don't need to calculate I5 actually, because it's already equal to IT. Now let's write all of the currents with respect to Is, and as I have said, I5 equals IT equals Is, and that's 100 milliamperes. For I4, by using the current divider rule, R over R plus R multiply with I, and the I going in is I5, and the resistors are R4 and R321. But the problem is we don't know R321. So the current input is I5, and let's see what's next later on after we have calculated the R321. But we can substitute R4 as 200. But again, we don't know what is R321. But let's just continue. Here is I3 going to the left, going down is I2, and going to the left is the I1. Now, what's I3? I3 is equal to the difference between I5 and I4. So I5 minus I4 by KCL, we can get I3. I2, on the other hand, will be using the current divider rule again, and the R involved here will be R2 and R1. And the current going in will be the I3. Then, finally, we have the I1, which will just be the difference between I3 and I2. Now, going back with the R321, we have to calculate the R321. And looking here, we have R3 in series plus the parallel of R1 and R2, or R2 parallel to R1. So, we will get R3 plus R2 R1 over R2 plus R1. Let's put the proper parenthesis here. And let's substitute the value of 500 plus the R2 of 400 multiplied with 300 R1 over the sum of 400 and 300. And by calculating this, we will see what will be the value of R321. Just be careful in using the parentheses in your calculator. You need to practice on how to calculate this properly to get the correct answer. So I got 671.428 ohms or 4286 ohms. I rounded 57 into 6 or 60. That's why it's like that. Then we substitute this R321 value on I4, and we will see the I5 is 100 milliamperes multiplied with the values given here. And let's use the calculator again. Let's multiply 671.4286 with 100 over the sum of the R4 and R321. And we will get the answer of 77.049 milliamperes. And then to get I3, we will get the difference between I5 and I4. 100 minus 77.049 milliamperes, we will be getting 22.951 milliamperes. And then for I2 with respect to the IS, we will substitute the values of R1 and R2 in our equation, and our I3 also of 22.951, and using the scientific calculator, let's multiply 300 with 22.951 milliamperes over the sum of 400 and 300, and we would get 9.836 milliamperes. Now for I1, finally, we get the difference between I3, which is 22.951 minus 9.836. Let's see the answer here. We will get 13.115 milliamperes. That's the final current I1. And there you go. We got all of the currents with respect to IS. Now remember that we have two solutions for I1, I2, I3, I4, and I5, and therefore we need to get the total currents or individual currents, and to do that, just subtract the bigger value from the smaller value from the bigger value. Let's see which is bigger, the I1 with respect to IS or the I1 with respect to VS. We have also to consider the direction so that we will know if we will add or we will subtract. And you see here, I1 VS is to the right and I1 IS is to the left. So I1 VS is to the right with 18 milliamperes and I1 IS is to the left with a smaller value. So we will see it's 13 against 18. So we just subtract 18 minus 13. Because the I1 with respect to IS is smaller, so we will get 18.0328 milliamperes minus the I1 with respect to IS, which is 13.115 milliamperes. And if you subtract 13 from 18, we will get, let's calculate now, we will get the answer of 4.9178 milliamperes. And then let's calculate the value of I2, which is going down with respect to IS, and with respect to VS, I2 is also going down. Therefore, we can add the two I2s, the I2 of the VS and the I2 of the IS can be added together because they have the same direction. So let's get the value of each. 11.475 milliamperes plus 9.836 milliamperes, both going down. Therefore, the sum of these two currents will be the final answer for I2. And that would be equal to 21.311 milliamperes going down. And then we have I3 with respect to IS. Let's see the direction. It's going to the left with a value of 22.951, and the other I3 is going to the right, but it has a lesser value of 6.5578. Therefore, the lesser value or the lower value will be subtracted from the bigger value. So I3 going to the left minus the I3 going to the right with respect to VS. Let's see the values of these two. And of course, the bigger value will be followed. The direction of the bigger value current will be followed in the final answer. Therefore, 22 minus 6 over here will be equal to, let's see the answer now. I'm subtracting the 6 from the 22, and we got 16.3932 milliamperes. And there you go for I3. And for I4, it's both going down with respect to each sources. With respect to VS and IS, both are going down. Therefore, we can add the two currents for I4. Let's get the values of the two I4s. So we have 6.5578 milliamperes plus another I4 of 77.049 milliamperes, and we would get the value of 83.6068 milliamperes. And finally, let's see that I5 is, with respect to IS, is 100 milliamperes. And the I5 with respect to the VS, so this one is going to the left or counterclockwise, but the I5 with respect to VS is equal to 0. Therefore, even if you add the I5 from the voltage source, it would be 0 anyway, and we will get the same answer of 100 milliamperes. So 100 plus 0 is of course 100 milliamperes. And there you go. We got the I5, I1, I2, I3, I4, and I5 currents. And now we are ready to calculate for all the voltages by simply using Ohm's law. And that would be I1 multiplied to R1 up to I5 multiplied to R5. So by just substituting all of the current values that we got from the previous calculation of currents for the current totals, and then multiply them by the individual resistors of R1 up to R5, and by Ohm's law, I multiply it with the R and you will get the voltage. That's how easy it is. But if your currents are all wrong, then your voltages will also be wrong. That's why be careful in calculating the currents, because voltage calculation is so easy. Now, if you multiply milliamperes with ohms, we would get millivolts, and it will be abnormally high. Therefore, we need to divide it by 1000 to get volts. And so, the 1475 will just be 1.47534 volts instead of thousands millivolts. The 8524.4 millivolts will become 8.5244 volts, and 8196.6 millivolts will become 8.1966 volts, and the 83 multiplied with 200 will be 16721.36, will just become 16.72136 volts, and finally the V5 will become 30,000 millivolts, or simply 30 volts. And there you go. That's how we do the superposition theorem applied on 5 resistors with 2 sources. One is a voltage source and the other one is a current source. I hope you learned something today about how to do this voltage source and current source combination in a series parallel circuit using the superposition theorem. Thank you so much for watching this video, and we hope that you support our channel, ERC Tipsnology, and have a nice day, everyone.